Alright, so in this video, we just want to explain what eccentricity is. Alright, so eccentricity is just a number associated with each conic section, and it reveals what conic section you're talking about. Literally, I can just say eccentricity is just, I think, the measure of how much a shape has deviated from being circular. Okay, so how much it has deviated from being circular. Okay. So if we look at the conic sections that we've already discussed so far, we've talked about a circle, we've talked about an ellipse, we've talked about a parabola, and then we've also talked about a parabola. So which one do you think has deviated very much from a circle? So of course, just from the fact that we're saying how much a shape has deviated from being circular, this actually tells us to say a circle has not deviated in any way from being a circle, so the eccentricity of a circle is just a zero. The one that is closest to being circular among all these other shapes is an ellipse. So an ellipse, as we might expect, is supposed to have a value less than a 1. Okay, and then the one that has deviated the most from being circular is a hyperbola, so it has got an eccentricity value greater than 1. And then for a parabola, it's just equal to a 1. Okay, I'll explain why. So that being said, so there's no need of you to ever calculate the eccentricity of a circle and a parabola because they are known. Okay, that's 0. For a parabola, it's a 1. Now, how do we calculate the eccentricity of the other two, a hyperbola and an ellipse? Okay, I've already given you an hint to say for an ellipse, our value is always supposed to be less than a 1. For a hyperbola, it's always supposed to be greater than a 1. The formula for eccentricity is just given by C over A. Okay, where in terms of a hyperbola, if I was to give you a hyperbola here, like that, the distance from the center to a vertex, okay, is A, and then the distance from the center again to a focus is C. Okay, so that's what we're talking about in terms of a hyperbola. That's what the C and the A are representing. So C is representing a distance from the center to the focus, and then A, the distance from the center to the vertex. Okay, some textbooks might define the eccentricity to be the distance between the foci, meaning that you measure from one focus to the other, okay, which of course would become 2c, and then also the distance between the vertices. So that would give us 2c over 2a, which will still be c over a. Okay, so I've established a is c over a. Now the formula of a hyperbola, we already know to say it's actually, whenever we're talking about a hyperbola, if you go back to the original definition of a hyperbola, you see that it's actually a difference, right? Okay, you measure distances, the difference between the distances to the foci is a constant. Okay, so how does that look? So you've got the foci somewhere there and the foci somewhere there. Get any point on the hyperbola like that, and then measure its distance to the two foci, or the two focus, which is foci to a foci. The difference there is a constant. So the formula is x squared over a squared and then minus y squared over b squared. This is in a case where it is along the x-axis. Okay, that is our formula there. So that being mentioned, you also need to know that eccentricity, in this case c over a, how do we find the c for the hyperbola? It's actually going to be So a secret is just change the sign if you're confused. So it's going to be a summation of a squared plus b squared over a. And then for the ellipse, it's a different scenario. Since it's supposed to be less than 1, it's going to be a squared minus b squared, just like we do. Okay, so c over a. That's how we find the eccentricity of an ellipse. Okay, so I've given you a lot of tips that can help you remember the formulas for both of these. Let me leave them out there for you. You know the equation of the basic form of an ellipse is going to be in terms of addition, right? Okay. So obviously when it comes to its eccentricity, you change the sign there. Okay, that being said, what else have I not mentioned about these? Yeah, I haven't explained to you why so we can also actually define the eccentricity in terms of the distance to the focus, okay, divided by the distance to the directrix. Okay, so in a case of a parabola, we understand that there's a line what we call directrix, and then there's an inner point that we call the focus. The distance from any point on the parabola to the focus and also the directrix is actually the distance is actually the same, so they are equal. So you would actually understand why the eccentricity of a parabola is a 1. Okay, I think let's look at some few examples here we see. Okay, assume you're given 4x, not 4x, let me start with, let's say we have 9x squared. Assume we have 9x squared plus 25y squared is equal to 225. So determine the eccentricity of this shape. To start with, what shape is this? So observe is a summation there. So is it an ellipse? Is it a hyperbola? Whenever you see an addition there. So the moment you say an addition, just know it's an ellipse because you understand that comes from its definition. Okay, it has got the foci inside of itself. So if you try to measure distance to the foci from any point on the ellipse, call that d1, call that d2, their sum is a constant. Okay, so we're dealing with an ellipse, so we expect that e should be less than a 1. Okay, and therefore want to put it in the form where we've got a 1 on the right. So divide both sides by 225, 225, 225. What do we end up with? So 9 into 25 is how many times? 25. So x squared over 25. 25, it's a 1. 25 into 25 is 9 times. Okay, 9 times. And then that is just equal to 1. So we have our basic form for the ellipse. Okay, so this is greater than the 9, right? So you can have x squared over 5 squared plus y squared over 3 squared. We're just expressing them in terms of squares because that's what the basic formula tells us, right? So we understand that the first part, where there is 5, it's a, and then where there is 3, it's b squared. And of course, most people usually get confused. How do I know which one is a, which one is b? So a is going to be greater than b in a case of an ellipse. Okay, the reason is very, very simple. Okay, when you look at the foci is inside for an ellipse, so that's why b is actually, if you take it in terms of c, that's why I actually find that c is actually smaller. Okay, so therefore our eccentricity here is c over m. Now our c in this case, there's an addition there, so let's put a subtraction. So we're going to have a squared minus b squared over c, sorry, a. Okay, so our a is 5, so 5 squared minus 3 squared over our a, which is 5. So 5 squared is 25 minus 9, that's 16. So we end up with root of 16 on top, which will give us a 4, and then we've got a 5 down there. So 4 over 5, which is less than 1. That's the eccentricity of that ellipse. Okay, very simple and straightforward, right? Feel free to pause the video and try this very simple one. And as you might guess, this is, what shape is this? Okay, so pause the video and try this one out. So we have x squared over 4 squared minus y squared over 3 squared is equal to 1. So what shape is this? In fact, it's a minus. So this is a parabola. Okay. So a parabola has very much deviated from being circular, so the value should be greater than 1. So E is equal to C over A. And then our C, we'll just do the opposite of what we have. So we're going to have A squared plus B squared over A. A squared is 4 squared, 3 squared over A. So we're going to have 16 plus 9 on top, which will give us 25 over our A is a 4. So we're going to have 5 over 4, which is of course greater than 1. Okay, that's how you handle these two basic questions. Now I've got 3 more questions that I want you to try out. Question 1, we're told locate the vertices of an ellipse of eccentricity 0.8 whose foci lie at the points 0, plus or minus 7. So it's very easy to handle these questions if you know the shapes they're discussing. An ellipse. An ellipse. Okay. So how do I know that this ellipse is longer along the x-axis? Based on the fact that we are told the foci is what? Actually, the foci is actually the y value in this case. Okay. Okay, so in that case, it's supposed to be along the y-axis. Okay, like that. It's supposed to be like this. Okay. So plus or minus 7. So that's a foci, right? So positive 7 and negative 7. Okay, assuming the center is about the origin. Okay. So one there is positive 7, one is negative 7. Okay. What are we told? We are told to locate the vertices of an ellipse of that eccentricity 0.8 whose foci lie at the points 0, plus or minus 7. How do we do it? So the other formula that you should know is eccentricity is given as, what did you say? We said the distance to, in fact there is this other definition. I said the distance between the foci divided by the distance between what? The vertices. Okay, that's another formula that we actually talked about. So distance between the foci, distance between the vertices, it gives you the eccentricity. So eccentricity in this case has been given to be 0.8. Okay, so therefore we've got E is equal to our E is 0.8. Okay, now we've given plus or minus 7, so that 7 is a distance to the foci. Okay, so distance to the foci is 7, and then we don't know the distance to what? The distance to the vertex. Okay, this is the way that I actually put it. So I said when you're looking at an ellipse, C is representing the distance from the center of the ellipse to the foci, and then A the distance from the center to the vertex. Okay, and that's why in an ellipse you see that the value is actually going to be less than what? Less than 1, because the denominator is greater than the numerator. So try to find x. You're going to have 7 over 0.8. Okay, grab your calculator there and try out this basic question. So you're going to end up with 8.75. Okay, so our focus was just trying to find the vertex along the major axis. So this would be 0 plus or minus 8.75. So implying 1 would be there, 8.75, 1 would be down there. Okay, so you've seen that actually picturing the diagram helps you to simplify the question faster and easier. I want to look at this one, find the eccentricity of the hyperbola. So from looking at a similar question, I think now I have some courage and pause the video and try this one out. This one they've specified this is a hyperbola. Eccentricity is given as c over a. I already showed you how to find c. I gave you a hint. Since it's positive, it's negative there, just, you know, do something there over c. So that's going to be a squared plus b squared, and you expect it to be greater than 1. Okay, so divide throughout by 144, and yeah, be able to get the answer there. Okay, so feel free to comment out your answer. So the answer that you should actually get for eccentricity here should be 5 over 4, or simply 1.25. And then the last question here is find the Cartesian equation for a hyperbola centered at the origin, that as the focus, at 3, 0, and the line x is equal to 1 as the corresponding directrix. Okay, so this takes us back to the other basic formula that I gave you. I said eccentricity in terms of when you looked at the parabola, what did we say? We said the distance to the focus divided by the distance to the directrix. Okay, so what are we trying to do here? What are we told? Here we are told we need to find the Cartesian equation. So we need to find the equation for this hyperbola. Now we are told centered at the origin, that as a focus. So that's our focus, 3, 0. Okay, and then the line x is equal to 1. So distance to the focus, if you look at this hyperbola, this is the way it is. Distance to the focus has been given. So if you look at it, it's 3, 0, 3, 0. So that implies you've moved. So that would be somewhere maybe there. Okay, 3 units too along the x-axis. So 3, 0. So that would become a distance from the center to the focus. So we may assume if the center is about the origin, that would imply on the other side it would be -3, right? That's what it would imply. So remember, the foci for the hyperbola is beyond the vertices. The vertices are these points. Okay, so therefore the distance side is just 3, and then the distance to the directrix as well, in this case, in this rare case, is actually at x is equal to 1, so which is 1, 0. Okay, so that will imply we have a 1 on the bottom, so giving us an eccentricity of 3. Okay, which now, if you want, we can actually make most of it to help us simplify what we have. Okay, so the formula, on the other hand, we said eccentricity is actually c over a. Okay, we can actually try to make most of that and see what we end up with. So in that case, we'll see that a in this case is equal to a 1. So now let's try to find the missing one, which is b, right? We need to find b. Now the top part we said is c, so c is equal to 3. What did I tell you? I told you to say e is equal to c over a, and then c is, what are we dealing with? Hyperbola. What's the basic form of the equation? Is it minus or negative? So this is the negative. Okay, so therefore we're going to have an addition there. So c is equal to the root of a squared plus b squared. Our c is 3, our a is 1, our b is what we don't know. So square both sides so that the square root can disappear on the right. You have 9 minus 1 is equal to b squared, and then b squared becomes 8, right? So b squared becomes 8. Okay, so let's not forget that our a is 1. So if we were to substitute for a squared, that's going to be a 1. And then for b squared we found 8. So we'll have 8 there. And then of course dividing by 1 is just as good as not putting it there. And then y squared over 8 is equal to 1. So that's the equation, Cartesian equation for this hyperbola, based on the concept of the directrix or eccentricity, helping us to find the value of a and b. Okay, so that's it to this video. I hope you've understood what eccentricity is. And if you want to have access to the entire conic section topic, use the link in the description below to access the video either on Patreon, on our site, or YouTube Premium. Thank you very much for watching.